Hi everyone, today my video is about data reduction in data mining. What do you mean by data reduction? The method of data reduction we achieve a condensed description of the original data which is much smaller in quantity but keeps the quality of the original data. It means that it is a reduced description of the original data and it is much smaller in quantity but it also keeps the quality of the original data. There are different methods for data reduction. Let us look what are they. First one, data cube aggregation. This technique is used to aggregate data in a simpler form. For example, imagine that information you gathered for your analysis for the years 2012 to 2014. That data includes the revenue of your company every 3 months. They involve you in the annual sales rather than the quarterly average. So we can summarize the data in such a way that the resulting data summarizes the total sales per year instead of per quarter. So it summarizes the data. So this is a technique of data cube aggregation. Another method is dimension reduction. Whenever we come across any data which is weakly important, then we use the attribute required for our analysis. It reduces data size as it eliminates outdated or redundant features. There are different methods for dimension reduction. First one is stepwise forward selection. This selection begins with an empty set of attributes. Later on, we decide best of the original attributes on the set based on their relevance to other attributes. We know it as a p-value in statistics. Suppose these are the following attributes in the data set. Here we see initial attribute set is given as x1, x2, x3, s4, x5. So in stepwise forward selection we took an empty set. So the initial reduced attribute set is given as an empty. Then we will look the best of the attribute. Step 1 we select x1, then step 2 we elect x2, then the set becomes x1, x2. Then the step 3 we select x5, then step 3 the set is x1, s2, x5. So the final reduced attribute set is x1, s2, x5. So the stepwise forward selection means it will begin with an empty set and later we decide best of the original attributes of the set based on their relevance to other attributes. Another method is stepwise backward selection. This selection starts with a set of complete attributes in the original data and each point it eliminates the worst remaining attribute in the set. Suppose these are the following attributes in the data set. Initial attribute set is given as set x1, x2, s3, x4, x5. Then initial reduced attribute set is x1, x2, s3, x4, x5, s6. Then the initial attribute set is x1, x2, s3, x4, x5, x6 and reduced attribute set is x1, x2, x3, x4, x5, x6. The step 1 is we are eliminating each one in each step. So step 1 becomes x1, x2, s3, x4, x5. Here x6 is reduced. Then step 2 x1, x2, x3, x5. Here x4 is removed. Then step 3 it becomes x1, s2, x5. So the final reduced attribute set is set x1, x2, x5. Just remember that we are starting with the set of complete attributes in the original data and each point we eliminate the worst remaining attribute in the set. Such a process is called stepwise backward selection. Then another method is combination of forwarding and backward selection. It allows us to remove the worst and select best attributes, saving time and making the process faster. Then another method of data reduction is data compression. Data compression technique reduces the size of the files using different encoding mechanisms such as Huffman coding and Rowland encoding. We can divide it into two types based on their compression techniques. There are lossless compression and lossy compression. In lossless compression, the encoding techniques allows a simple and minimal data size reduction. Lossless data compression uses algorithms to restore the precise original data from the compressed data. Another is lossy compression. In lossy compressions, methods such as discrete wavelet transform, PCA, principal component analysis are examples of this compression. For example, JPEG image format is a lossy compression, but we can find the meaning equivalent to the original the image. In lossy data compression, The decompressed data may differ to the original data but are useful enough to retrieve information from them. So, there are difference between lossy compression and lossless compression. Just we look through that. Lossy compression. First one, lossy compression is the method which eliminates the data which is not noticeable, while lossless compression does not eliminate the data which is not noticeable. Second difference is, in lossy compression, a file does not restore or rebuild in its original form, while in lossless compression, a file can be restored in its original form. The third difference is, in lossy compression, data quality is compromised, but lossless compression does not compromise the data's quality. The fourth difference is, lossy compression reduces the size of the data, but lossless compression does not reduce the size of the data. Fifth difference is, algorithms used in lossy compression are transform coding, discrete cosine transform, discrete wavelet transform, fractal compression, etc. Algorithms used in lossless compression are London encoding, Lembel SULH, Hammond coding, arithmetic encoding, etc. Sixth difference is, lossy compression is used in images, audio, video, while lossless compression is used in text, images, sound. Seventh difference is, lossy compression has more data holding capacity, while lossless compression has less data holding capacity than lossy compression technique. So these are the difference in lossless compression and lossy compression. Next, another dimensionality reduction is numerosity reduction. In this reduction technique, the actual data is replaced with the mathematical models or smaller representation of the data instead of the actual data. It is important to only store the model parameter, or non-parametric methods such as clustering, histogram, sampling is used. Numerosity reduction are of two techniques, parametric and non-parametric methods. For parametric methods, data is represented using some model. This model is used to estimate the data so that only parameters of data are required to be stored instead of actual data. Regression and log linear methods are used for creating such models. But next we look what is regression. Regression can be a simple linear regression or multiple linear regression. When there is only single independent attribute, such regression model is called simple linear regression. If there are multiple independent attributes, then such regression models are called multiple linear regression. So if we are depending on a single variable, you remember it is a simple linear regression. If it is dependent on different attributes, it is called multiple linear regression. For example, a random variable y can be modeled as a linear regression of another random variable x with the equation y is equal to ax plus b, where a and b are regression coefficients, specifies the slope and y-intercept of the line respectively. Then, in multiple linear regression, y will be modeled as a linear function of two or more predictor variables or two or more independent variables. Another is log linear model. Log linear model can be used to estimate the probability of each data point in a multidimensional space for a set of discretized attributes based on a smaller subset of dimensional combinations. This allows a higher dimensional data space to be constructed from lower dimensional attributes. Regression and log linear model can both be used on sparse data, although their application may be limited. Then another is non-parametric methods. These methods are used for storing reduced representation of the data. It includes histograms, clustering, sampling, and data cube aggregation. What do you mean by histogram? Histogram is the data representation in terms of frequency. It uses binning to approximate data distribution and is a popular form of data reduction. Another is clustering. Clustering divides the data into groups. This technique partitions the whole data into different clusters. In data reduction, the cluster representation of the data are used to replace the actual data. It also helps to detect outliers in data. Another is sampling. Sampling can be used for data reduction because it allows a large data set to be represented by a much smaller random data sample. Another is data cube aggregation. Data cube aggregation involves moving the data from detailed level to a fewer number of dimensions. The resulting data set is smaller in volume without loss of information necessary for the analysis task. Next, we look discretization and concept hierarchy generation. Techniques of data discretization are used to divide the attributes of the continuous nature into data with intervals. We replace many constant values of the attributes by labels of small intervals. This means that mining results are shown in concise and easily understandable way. There are two types of discretization. First one is top-down discretization. If you first consider one or a couple of points to divide the whole set of attributes and repeat of this method up to the end, then the process is known as top-down discretization, also known as splitting. Then another is bottom-up discretization. If we first consider all the constant values as split points, some are discarded through a combination of neighborhood values in the interval. That process is called bottom-up discretization. Next, we look what is concept hierarchy. It reduces the data size by collecting and then replacing the low-level concept, such as, for example, such as 43. We are replacing it with the word age. For high-level concept, if the middle age, it is replaced by the word middle age or senior. So it is known as concept hierarchies. It reduces the data size by collecting and then replacing the low-level concept. For numeric data, following techniques can be followed. Binning. Binning is the process of changing numerical values into categorical counterparts. The number of categorical counterparts depends on the number of bins specified by the user. Next is histogram analysis. Like the process of binning, histogram is used to partition the value for the attribute text into disjoint ranges called brackets. There are several partition rules: equals frequency partitioning, equal width partitioning, and clustering. Equal frequency partitioning. Partitioning means the partitioning the values based on the number of occurrences in the data set. Then equal width partitioning. Partitioning the values in a fixed gap based on the number of bins. A set of values ranging from 0 to 20. Another is clustering, grouping the similar data together. Today in this video I told about what is data reduction. If you like the video, you please subscribe and put comments and share. I will come with the next video. Till then, bye.